Welcome to The Explainer. Today, we're diving into something absolutely wild. We are going to track the meticulous, almost magical process of taking a tough, woody plant right out of the dirt and engineering it into one of the most luxurious fabrics on the planet. We're talking about the 100-day journey of European linen. It is a fascinating story, really, blending ancient agricultural wisdom, microscopic biochemical warfare, and some seriously heavy-duty mechanical engineering. Here is our roadmap for today. We're going to hit the 100-day harvest, get into the science of retting, look at extracting the flax fiber, follow it into spinning the linen yarn, set up for weaving the final fabric, and wrap up with the ultimate heavyweight showdown, linen versus cotton. Let's get into it.
Section 1. The 100-day harvest. From dense seeds to golden stalks.
100. That's the magic number. It takes literally just 100 days for a fragile little flax seed to become totally ready for harvest, making it a rapidly renewable resource. Now, flax primarily thrives in this specific damp coastal strip from France up to the Netherlands. Actually, France is the world's leading exporter, shipping massive amounts of this premium flax to global textile manufacturing hubs like China and Vietnam, where the breathable nature of the final fabric is in massive demand. So how does that 100-day timeline actually play out? On day 1, farmers do a dense, shallow sow, just 1 to 2 centimeters deep, and they intentionally crowd the seeds. Why? Because forcing the plants to compete for sunlight means they shoot straight up without growing any side branches. No branches means you get the longest, strongest possible fibers. Fast forward to day 71, and the fields just erupt in these gorgeous blue flowers, but they only bloom for a single day before turning into seed heads. And then, right at day 100, the lower stem turns a golden yellow. That's the signal. It's hit technical ripeness. Now check out the very first step of the harvest, pulling. They don't cut the flax. They pull it completely out of the ground, roots and all. If you cut the stalk, the valuable sap literally leaks out and the fiber length is immediately cut short, which obviously tanks the financial value of the crop. So once pulled, the stalks are bundled into what are called beets to dry out in the field. That's called stooking. Finally, a gentle combing process called rippling removes the seed bolls, which they either save to replant or press into linseed oil.
Section 2. The science of retting, a controlled biochemical battle.
Okay, so you've got these dry stalks, but the soft fiber we want is trapped inside. To get it out, we have to use a process called retting. It sounds like a bit of archaic jargon, but retting is essentially a highly controlled rotting process. Fungi and bacteria are left to eat the pectins, the natural glue holding the bast fibers to the woody core, and it is a high-stakes biochemical tightrope. Pull the flax out too early, it's under-retted, and the fibers won't separate. Leave it too long, it's over-retted, and those hungry microbes will actually start eating and ruining the precious fibers themselves.
And there are 2 ways this historically happens. Dew retting is the gold standard today in optimal climates like Western Europe. The stalks just sit in the fields for 3 to 7 weeks, relying entirely on natural rain and dew. It's totally chemical-free and highly sustainable. Water retting, on the flip side, means submerging stalks in tanks or rivers. It's way faster, like 1 or 2 weeks, but it creates the severe biological wastewater that just starves rivers of oxygen. That's exactly why sustainable European growers have completely ditched it for dew retting. Section 3. Extracting the flax fiber, the mechanical gauntlet. All right, the pectin glue is dissolved, but now we've got to literally smash, scrape, and comb the retted plant to get our treasure. First up is breaking. Fluted rollers crush the brittle woody core into tiny pieces called sheaves without snapping the flexible outer fibers. Then we have scutching, which beats all those woody fragments away. And lastly, hackling, to purify and align what's left. It's a chronological gauntlet where every step strips away more waste. Let's zoom in on scutching for a second. Historically, this meant a farmer standing there for hours, manually beating the broken stalks with a wooden knife. Today, we use these massive automated turbines that can process up to 500 kilograms an hour. But the crazy thing is, they rely on the exact same physical scraping principles developed centuries ago to knock the sheaves out. Then there's hackling. Think of this like using a really fine tooth comb on incredibly tangled, long hair. The scutched flax gets pulled through these progressively finer beds of sharp iron nails. All the short, coarse, tangled fibers get yanked out. That's called the toe. And what you're left with are the long, parallel, absolute premium fibers, known as the line, which are heading straight for the luxury fashion market.
When you consider the sheer mechanical force and precision handling required, this quote really hits the nail on the head.
I am in awe of the fabric and the people who produced it, one back-breaking season after another. Even with modern machines doing the heavy lifting, the legacy of that intense, back-breaking labor is literally woven into the identity of linen. Section 4. Spinning the linen yarn. From fiber to thread. We're out of the fields and into the spinning mill, and here, water is a total game changer. Wet spun linen uses hot water during spinning to produce this incredibly fine, smooth, lustrous yarn that high-end fashion brands go crazy for. Dry spun linen is spun without any water, and it gives you a much coarser, highly textured yarn that's perfect for things like heavy upholstery or even industrial ropes. For that premium wet spun yarn, temperature is absolutely crucial, 60 to 70 degrees Celsius. When the fibers pass through a hot water bath at exactly this temperature, any leftover pectin softens up. This lets the spinning frames stretch the fibers way farther without snapping them, and it smooths down all those microscopic flyaway hairs, kind of like running warm water over your own hair. The result is a glossy, incredibly strong thread. Section 5. Weaving the final fabric, looming and finishing. So our yarn is perfectly spun and interlaced on the loom, but straight off the loom, linen is called greige, and honestly, it is stiff as a board. Plus, raw linen yarn hardly stretches at all, so it's constantly at risk of snapping under the tension of a high-speed loom. To prevent these catastrophic thread breaks, weaving mills have to keep the humidity perfectly controlled, sometimes even misting the yarns with water while the looms are actively running. How do we get from stiff, unyielding greige to a soft, comfortable shirt? Through some really clever finishing treatments. Stonewashing uses actual physical friction to relax the weave. Enzyme washing is this super cool, eco-friendly method where enzymes basically eat the tiny surface hairs to soften the fabric. Sanforizing hits it with steam to pre-shrink the material so it doesn't shrink in your washing machine. And calendaring crushes the fabric between heated steer rollers, flattening the yarns to give it a premium crisp luster. Section 6. Linen versus cotton, the ultimate textile showdown. Now let's break down the data to see exactly why these fabrics feel so completely different. Look at elongation. Linen only stretches around 3%, while cotton stretches up to 7%. That rigidity is why linen feels so crisp and, yeah, why it wrinkles if you just look at it wrong. But check out the moisture regain. At 10 to 12%, linen absorbs and dumps moisture way faster than cotton, keeping you cool on a hot day. Plus, it has a slightly higher specific gravity, making it denser, which gives it that heavy, elegant drape. And then there's this massive environmental factor, 4x. Cultivating flax requires up to 4 times less water than cotton. It just thrives on regular European rain without needing massive irrigation. And financially, it's a zero-waste stream. The long fibers make fashion, the short toe goes into paper or insulation, the seeds become oil, and the woody shivs are sold for animal bedding or bioplastics. Every single piece is used.
To sum up this incredible journey, you've got 100 days of rapid growth, a controlled biochemical retting process, and a really intense mechanical gauntlet. And it all results in a zero-waste premium textile. From a crowded rainy field in France to spinning mills and massive markets in China and Vietnam, making linen is an absolute masterclass in engineering a natural resource to its absolute maximum potential.
Which leaves us with a pretty compelling question. As the entire textile industry struggles with extreme water usage and synthetic pollution, is this ancient, zero-waste, highly durable engineering of European linen the ultimate blueprint for the future of sustainable fashion? Next time you put on a linen shirt, think about the science and the labor that went into it. Thank you so much for joining me for this explainer, and I hope this sparked your curiosity to keep exploring.